A Wi-Fi access point without Ethernet. A Wi-Fi access point with Ethernet. That's our goal for today. Good morning, everybody. Lots of people here. Before I get into saying hello to everyone, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, yeah, there's been a lot of chat already in the chat. Austin Michael, TNT, our TNT WX watcher is about to snow here in Colorado. So we've got a couple of people worried about snow. Austin, who wants the snow so he can try his new snow blower. And Cable Tie, who didn't go out for a ride today because of the potential storm. Lots of people here. So, Michael is here. Dodgy is here, of course. Tony is here. I've already said hi to Cable Tie. Who else do we have? Family Plans is back. Russell, Mr. Fixit, DIY, Peter, Mad Techie, The Lane, Tradie, Simon, Scott. Yes. Good morning, everybody. We had a couple of very brief blackouts where I am last night during the night because there was a bit of a storm, and there was a really bad storm over near where Tony is, which is west of me by how far? I don't know, maybe 600-700 kilometers, something like that. And there are a lot of people that are going to be without power over there for a day or two. Oh, Peter said, wait, I can't start lunch monitor duties. I'm not even dressed. Get some pants on. Come on, Peter, you can't be watching a live stream without pants on. 800 kilometers, Tony says. Yeah, something like that. So the way the weather works down in this area, part of the southern hemisphere, it comes across because of the Coriolis forces and everything. It tends to travel from west towards east. So whatever Tony sees, I am likely to see a day or so later. Jordan made it late, but not too late. No, you're not late at all. I'm just saying goodbye to everybody. Hey, Chip, outside the box is here. Awesome. Okay. Yeah, as Michael says, the old saying about Melbourne weather is that if you don't like it, just wait 10 minutes. Stephen W., you can't force us to wear pants. No. Right. Scott, yes, of course you're right, because the the Earth is not two semi-spheres that spin in opposite directions. It's a single sphere that spins in the same direction. Peter says, Steve, proof of life demand. Yeah, Steve is just up here. And Steve says, hello, Austin. I missed out on seeing your snowblower. So, for those of you who don't know the backstory, Austin sent me Steve all the way from Canada. Yes. Cable tie. I'm very glad that this is not a Zoom meeting. Too many references to pantlessness. And Scott says, imagine trying to cross the equator if it did. Yes, that would be... okay, let's not get into that. That would... The relative speed of the two surfaces of the two semispheres as they passed each other would be rather ridiculous. Scott Miller gets the credit for Steve. Yeah, so Scott came up with the name for Steve, I believe, and Austin sent me that actual Steve, that incarnation of Steve, because Steve is not a single squirrel. Steve is a concept. We're all Steve. I am Steve. No, I'm Steve. What is the speed of a fully laden swallow? Is that... what's that one? Is it the... but are you talking about the European swallow or the African swallow? I can't remember. Whatever that reference is. Because there is a difference, you know. Scott says, I had Steve delivered to Austin for the shipment. Interesting. I don't think I was ever aware of that, Scott. That's cool. Well, thank you to both Scott and Austin. Did you test Bodge PoE? No, I did not. Okay, we are going to... Oh, look, the bots have found us. Maybe one of the moderators can... oh, thanks, Austin. You deleted the message. Maybe we can block that user. It's just going to keep spamming the chat otherwise and annoying the... Oh, timed out by Peter. Thank you. Okay, enough messing around. What am I doing? Okay, so today, let's open up. I'm just going to open something here. Go back to resources. Where are we? No, not resources. Notes. Notes. Yes. Just wondering if I should open this in Vim. I just double clicked the file and it opened in Apple and the Apple text editor, which is suboptimal, let me say. But that's okay. So here are some notes that we took last week as we were messing around with this access point and getting things working. So, validation, the different things we need to check. The button input worked perfectly first time. Total miracle. Something had to work. RGB LED output worked, and that was not a problem. MAC address ROM. Okay, so this is one that... This is where my poor memory is a problem. This is why I write notes to myself. I am absolutely sure that on a different disk image running on a Raspberry Pi, I have talked to that microchip MAC address ROM over I2C. I know that we saw its I2C address last week when we scanned the bus, but I'm pretty sure that I have actually read from it. And yesterday I went looking for my documentation on what I'd done, what script I had run in order to actually query it, you know, what drivers or whatever. Couldn't find anything. I've got no reference to it whatsoever. And then I Googled for drivers and things for it, using either Python or just like anything on Raspberry Pi. Couldn't find anything useful, which is very strange. So it's possible that I had a lucid dream and I dreamed that I got the MAC address ROM going. And okay, I'm going to have to come back to that and do some more digging, because that is not the main focus of today. Main focus is line 1, obviously, but we'll get back to that. Pi hat EEPROM. So this is going to become relevant after getting the first item going. We'll get back to that. Temperature sensor, that's probably going to be a bit of digging around, because it looks like there is no off-the-shelf driver for that temperature sensor that's on the board. Now this is what Austin was referring to. I screwed up the connections on the taps from the transformer coming off the RJ45 jack, and so power over Ethernet works with 802.3 AF, but it doesn't work if I just send 12 volts down the line. And so Peter's saying coffee break. What? Oh, Henrik, g'day. Coffee break for you, maybe, not for me. I'm a whole 8 minutes into this live stream, 9 minutes. But I do need to cough. All right. So power LEDs, that fails only just because they're so bright. They actually do work, but they work too well. So maybe they have an excess of success. That's better. And these are my notes from Austin's comments last week about fixing the power over Ethernet. So Austin asked in the question about, asked in the chat about whether I had patched the connections to that power over Ethernet thing. So that's something that we can experiment with today if we get to that. But this is the critical thing, the W5500 Ethernet, because if we can't get Ethernet going, then we don't have an access point. We just have a... Ooh, cool. So DIY in the ghetto says, hey John, I got the 5500 working on the Pi Zero. Nice. And Tony Smith has also done a lot of work on this and has done a custom overlay, or 2 custom overlays, and a startup script and a thing that generates a MAC address. So that's where I'm going to start. But DIY in the ghetto, yes, maybe you will have some clues along the way as well, because I am out of my depth with this stuff. I am just trying to figure stuff out as I go. I've never used overlays before on Raspberry Pi. So that is going to be a learning experience. All right. Well, I suppose the first thing is this little thing. It's not even powered up. You can see that there are LEDs on. Oh, hang on. Is it powered up? Yes, it is powered up. But it's been shut down. So it's not running. You can see that the RGB LEDs are turned off. The reason that this is flashing is that it is powered up, and the Ethernet chip, that one right there, is seeing the connection from here. So, and it's, in fact, it's showing a connection and it's showing activity on the network, even though the device isn't even running. So I'm going to unclip this Ethernet cable and we should see those LEDs change. So the connection has gone away and there's no activity. I'll plug it back in. If I can do it when I'm looking in the opposite direction and it's hidden from me, I'm going to have to use my eyes. There we go, plug it back in, and now we have Ethernet. But what I'm going to do is power cycle this so that it boots, because I shut it down and left it plugged into power. Alright, so it's turned off, power is back on. Oh look, the LEDs have come up with random colours. Well, some with the blue element activated, some with the green element activated. In a moment, they should all start flickering rainbows, which means that Raspberry Pi OS has booted. There we go. It's all washed out on camera and it looks like it's kind of just white unless I put it at an angle, but that is blinking rainbows now. If I chuck this on, maybe it'll diffuse. No, you can't really see it. It's too bright in here. So it is now running, and we can, Michael says, without Ethernet we have a ceiling mounted small storage device. Yeah, like a Wi-Fi little drop box or something that you could connect to wirelessly and mess around with. So let's get onto that, make this nice and huge so that we can read what's going on. So let's get onto it. What was the IP? 234, wasn't it? 192.168.1.234. And there, I have been messing around with this a little bit, and there are some leftover things, so I'm going to remove that. I want to start with a, I'm going to remove start Ethernet, and this will return us to the state we were in before. Actually, I'm going to do sudo rm boot overlays W5500 SPI1, because yeah, in the experiments that Tony and I have been doing, I've had a few problems getting it to start. So what I want to do today is start, oh hang on, you can't even see it. Sorry, I was on the wrong screen. So, thanks Cable Tie. So, what I want to do is start essentially from scratch, starting clean. DT overlay, is there a list command or something? No, overlay is loaded, okay. And so what I'm going to do is, I've just opened another terminal, but let's do this. I'm going to make that one the left terminal. This one I'm going to zoomify as well. Need to zoomify a bit more, I think. And I'll make that the right terminal. And then that one will go into there. And resources, W5500 overlay. No, I'm going to go back out of that. All right. So what I've got here in resources is a directory called W5500 overlay, which is you can see by my glasses. Okay. Yes. You need to do the zoom in, enhance, rotate 120 degrees, do the Blade Runner thing. So there is a directory, W5500 overlay. You're going to see what's in that in a second. But first up, I'm going to just copy it to 192, whoops, 2.168.1.234. Let's just stick it there. Okay, so it is now in here, W5500 overlay. All right, what we have in here are 4 things. The first is my notes that I've been taking as I've been playing around with it. And it's got things I've copied from messages that Tony has sent me. We also have the SPI1 off overlay. I'm not even sure if that's still required. I don't know. I don't know what's going on. We have W5500 SPI1 overlay. Okay, so a reminder here. Part of the complication with this is that the tutorials that you find online for doing things like, oh yes, Michael, I know, it adds the quotes around it. In fact, let's fix that. MB W5500 to W, let's just make it that. So normally Ethernet modules are added to the first SPI bus, which is SPI 0. And in this case, I'm adding it to SPI 1. I've got it on the second SPI bus. And the result is that the tutorials that explain how to connect a W5500 to a Raspberry Pi do not work. So I need to make some changes, and this is what Tony has been working on. So this W5500 SPI1 overlay, okay, cool, thanks Tony. So this overlay is what Tony has been working on to set up the appropriate things to enable it on SPI1. All right, so the process, the very first thing to do is, yes, I normally have an alias, in fact, let's do bash aliases. Is there a bash aliases? No. Is there a bash RC? Yes. Let's just do this. Do alias L equals CL ls minus L, something like that. I think that'll do it. Source dot. Alright. Now let's see if it works. Nope. What? CL not found? Oh, okay. I know why. There is no CL. There is clear. Now we should be able to do that, and now if I do L, that's better. Haha. Back into happiness. Alright, so then where was I? See, I'm chasing squirrels. But I'm back. I think I'm back. W5500 overlay. CD, W5500 overlay. Back into here. So what we want to do is copy this overlay into boot overlays. And now let's have a look at what is in Start Ethernet. Alright, so this does a couple of things. The first is that it gets the serial number. Okay, so just backing up a little bit. What the whole point of all of this chunk of it here is to generate a valid MAC address. and what it's doing is following the same process. So this is all Tony's magic. It's following the what it does is, yeah, it's following the process that is used by Raspberry Pi when they have their normal onboard Ethernet. There's no onboard Ethernet on the Pi Zero, so we can use this to generate a MAC that we want to use for the for this particular device. So the way the MAC address is constructed, the first part of the address, so that's the first 3 octets, are a prefix, and that is what this does is mean that everything within that, below that, like the whatever extra octets you add after this, it will be within the range allocated to the Raspberry Pi Foundation. So that means that you shouldn't have collisions with MAC addresses of other devices on the network. And then what we do is take the CPU serial number and use that to construct the other parts of the MAC address. So we could just run this script, but just for the fun of it, I'm going to step through it. So what we're doing is we're creating a variable here of serial by grabbing the serial number out of here. And then, so if we did echo serial, we should be able to see, and that is what it has just grabbed. So now what we're doing is taking portions of it and saying serial 1 equals blah. Let's just do both of these at once. Serial 2, serial 3. So it's taking subsections of that. This is chopping parts out of this, and then allocating it to these individual variables, and that's so that we can construct it with colon separators. Right. Cable tie says, I just went to copying and pasting from the YouTube screen. Yes. I do that all the time. When I'm watching tutorials and things, I'm really frustrated because I can't just copy and paste from the video. Although I'm sure copying and pasting from video will come. It's probably not that far off because extracting text from still images is pretty easy these days. There are apps you can get on your phone, for example, where you point it at a sign and it will extract the text from it, and you can do things like translations, like live translation apps. So being able to extract text from a video stream and make it selectable, probably people have already done it. It's just you can't do it on YouTube. I don't think it would be from a user. I'm chasing a squirrel now, but it's an interesting one. From a user interface point of view, that would be the biggest challenge. Taking a video stream and extracting the text from the stream, I don't think would be that hard. But then how do you represent it on screen in a way that you can select and in order to copy and paste it? That might be harder. Sorry, I should have muted before gulping water then. Alright, so if we just have a look at, say, serial 3. Come on. Serial 3, you'll see that it has a couple of digits out of it because this took from serial, from position 14, it took 2 digits, so it's grabbed that. And likewise, serial 1 and 2 would be 19 and EA, are my guesses. So next what we want to do is define address left, so we define the prefix, and then we define a colon variable, which might seem a bit strange, saying colon equals colon, but that is so that this section here can work. So that has now created the MAC address in adder, and if we do what it just says up above there, which is echo adder, look at that, we now have a MAC address. So the reason behind all of this is that the WISNet Ethernet controllers don't have MAC addresses assigned to them. We have to, in the configuration, it has to be told what its MAC address is going to be. And you've got to get it from somewhere. So this is the way we're doing it at the moment. This may well end up being quite valid, and there's no need to use the MAC address ROM. So I put the MAC address ROM on the PCB, and if we have to use that to get like a real valid MAC address, then that's fine, we can do that, but we may not need to. Mr. DIY says, are you trying to avoid X2, X6 local MAC addresses? Yeah, we're just trying to get a valid MAC address and make sure that it is dynamically generated, because we don't want to have to configure it every time and make it unique and try to keep track of it. I've done that in the past. Way back in the early days with Ethernet on Arduino, I had a big spreadsheet which listed all of the devices that I'd made and the MAC address that I'd assigned to it, and I'd have to be careful to increment the MAC address with each one that I made so that you wouldn't get weird things happening in ARP tables on the local network. I don't want that sort of pain, and that's the sort of annoyance that not very many people know how to diagnose. Yeah, so as Tony explained, I do it this way, as this is how the Raspberry Foundation allocates the MAC address on all Pis with a hardware Ethernet port. Yep. So doing it this way is perfectly valid. This is how the Raspberry Pi Foundation do it. It's just that they do it on boards that have an Ethernet port, and the Pi Zero doesn't have an Ethernet port. Now, where are we? Okay, down to here. So let's try. This is about the point where things can fail. Well, it's where things have been failing for me so far. So what are we doing? Sudo dt overlay. So we're setting the overlay SPI13CS, CS0, SPI, dev disable, CS1, SPI. Okay, let's just run that. And now this is the moment of truth. Oh, actually, before I do that, let's clear this and have a look if config. So the formatting is a bit messed up there. Let's drag that out to make it a bit easier to see what's going on. So we've got two interfaces on this device. We've got the loopback interface, and we've got WLAN 0, which is how we are connecting to it. So we're SSH'd in on WLAN 0. So let's have a look at start Ethernet again. This is the bit that has been exploding for me in testing up until now, so this is probably where things are going to fail. So what we're doing is, once again, DT overlay. We are calling the overlay. This is the .dtbo file that I just copied into place. We're setting the interrupt pin to 25, the chip select pin to 2. Oh, it's chip select 2. It's not pin 2, it's chip select 2. I don't know how it does its mapping for that. And we're setting the MAC address to what the MAC address has just been set to in this variable. So, aha, and now we have a failure. So this is where yeah, as Scott said, most common MAC conflict on the planet, dead beef feed. Yeah. So this is as far as I have got in the past. And so Tony has had this working on his test system, and I have not got it working on mine. And this is where the fun begins with debugging. Now, one thing that I don't know is whether the error that comes out of DT overlay, I don't think this could be caused by a hardware fault, but I'm not sure. Hey, Quindor is here. Intermittent tech, yes, cool. So just for you, Quindor, we have LEDs. LEDs are blinking. Okay, so there are, as a huge generalization, so this is an interesting point to get to in terms of bringing up hardware on a new project. The whole process of validation and validating the design. It's where things can become kind of stressful, for me at least, because the very first thing to try to figure out is this a software side problem or is it a hardware problem? And if it's a hardware problem, is it a design fault or is it an assembly fault? And because this is the very first board of this design that has been brought up, we don't know. Like, we're starting from no, this design has never been validated. This is the whole point of this process, is to, Tony says, let me generate a hardware fault and see what response I get. Yeah. So the whole point of this process, of what we're doing right now, is validating whether the hardware design is correct or whether it's functional. And it is. There have been a number of times where I've had a prototype that I've put together and then discovered, and then had lots of trouble with getting it to work, like drivers not being able to recognize devices and things. And I've discovered that the problem was not with the design, it was with the assembly. It could be, pins shorted on a chip or something like that. And then once you track that down, then it all works. But equally, there are many, many times that I've had situations like this where I'm trying to bring up a new design and it hasn't worked. And it's been because I've messed something up in the design side. And in that situation, what you can do typically is patch the PCB and fix whatever you've done. Because usually, with a few exceptions, sometimes it can be really, really hard. Usually, there will just be one thing that is wrong. And usually you can fix that by cutting tracks and putting in jumpers and that sort of thing. So yeah, the dreaded green wires or blue wires. And then you can check with the modifications applied to the board, you can get it working and then apply the modifications to the design, and then you're on your way. Wish it were QFN and not QFP, Austin says. It is. Oh, you wish it were QFN. You want QFN? So Henrik said, can you look at solder joints under the microscope? Yep, I have actually already done that, and I've reflowed it, and I'm pretty sure that the soldering is all good on the the 5500. Yeah, Austin says, I hate soldering the 5500. Yeah, but why is a QFN better than a QFP? I quite like drag soldering. I do a fair bit of that, so soldering the QFPs is not a problem. Okay, so Cable Tie said, so is this overlay working on Tony Smith's gear? And I believe the answer to that is yes. However, Tony doesn't have my hardware. He has a Raspberry Pi with a W5500 Ethernet module. I can't remember the part number of the module. And it's connected by jumpers. So it's one of those things where, in fact, I could find, let's, W5500 Ethernet module. I'm pretty sure I'd be able to find it quickly enough. Yeah, it's this. I'll just bring this up on screen somewhere. Yeah, I think the one that Tony is using is kind of like this. And it's the W5500 with a hand-run Ethernet jack on it. It's got the crystal and that sort of thing. And then the connection here, the SPI interface, connected by jumpers across to a Raspberry Pi. Henrik said, does Tony have the same chip? Yes, they're both the W5500 chip. And Trady asked, so how does Tony's design differ to yours? They should be very, very similar. So this is a generic module, and it pretty much follows the reference design of the W5500. And I've used the W5500 in other projects, including on the Rack 32 and yeah, a few other boards, pretty much following the reference design as well. So the design that is on this module, I didn't base mine on the module, but essentially they've got a common ancestor. They're both based on the reference design from WizNet. Yes, Cable Tie says, cool. So it could be design, could be assembly, and it could also just be software, like the environment. It could be that, I'll get to Aaron's point in a second. Yeah, so it could be that I have just messed something up on the software side. So in the environment here, in fact, let's just make sure this is all up to date. So as part of his testing, what Tony did was download the very latest Raspberry Pi OS to make sure that what he was testing on was the environment that would be most common for other people to also be using, because most people will be doing that. So I'll just make sure that this is up to date. Getting back to a couple of comments that I kind of skipped over. Aaron said, hey John and everyone, is it worth checking the pins you have declared in the script with what you have on the board while Tony is checking a hardware fault on his side? Yes, that is exactly one of the steps to go through. And typically at this stage, while I'm doing something like bringing up a new board, I will have Eagle open and I'll be going through and oh, interesting. Tony Smith said, swapped SPI data lines and overlay still loads. Yeah, so, sorry, I'm following multiple trains of thought here. I'll get back to that, Tony. So the, multiple packages can be upgraded. Just upgrade. I wonder if there's a new release. Okay, picking back up these multiple trains of thought. So yes, as Aaron said, checking about the pins. Now, what I'm usually doing at this point is I will have Eagle open and I will be looking at the pin allocations and checking them against whatever code I'm running to make sure that it is the same. And I have already done that, but it is worth doing it again because more eyes make bugs shallow. As the classic saying goes. I want to, sorry, I'm just clicking around here inside Eagle. Got to find the project and then I'll bring it up on screen so you can see it. IoT access point, here we go. And bring up the board. That doesn't need to be so big. And bring up the schematic. Bring that up here onto the little monitor so everybody else can see it. Alright, so Raspberry Pi 02 headers. This is where most of the critical information is going to be that we'll want to check. So we need to check SPI and Ethernet int and chip select are the critical things, because we've already validated I2C, validated the button, validated all the other stuff. So you can see here we've got this, down here we've got, this is SPI 0. So we've got Keepo, Copy, and clock, and those are all no connection on the board. Up here, oops, we have SPI 1. So now one of the assumptions here is that the pinout on the schematic is correct, and that is also something that should be validated. Yeah. Now, okay, I'm going to temporarily jump trains of thought and I'm going to come back to what's on the schematic, because there is a very important point here which which a couple of people alluded to. Yeah, so a lot of what Tony has been looking at right now is whether the overlay loads if there is a hardware fault. And where am I going with this? That's right. So the error, the meta question I suppose to ask is, the error that we're seeing when we run this, no, not that. What's going on with that? Service temporarily unavailable. Oh, interesting. Internode mirror is down. But the, cat start. Okay, so the error that we get when we run this, is it possible for this error to be caused by a hardware fault? Or will loading the overlay always work regardless of whether the hardware is connected or not? And so, like for example, if you had a Raspberry Pi which didn't even have a WIZnet chip on it, could you load that overlay? I think the answer is yes. So I believe where I'm going to with all of this is that seeing this error to me indicates that this is more like a software side environment problem rather than a hardware problem, which doesn't mean the hardware is fine. That's a next step down the track. I could be wrong, but to me this just feels like there is something in the environment on the Raspberry Pi which is not working properly, and it's not the hardware at this point. But we'll get back to that. Okay, so Austin said that he traced out the pins and they were correct. Cool, thank you, Austin. Austin is, he's picked up my problems a few times, so I know he's fastidious about this sort of thing. So thanks, it's good having an extra pair of eyes on that. So what we have is Keepo, Copy and serial clock for SPI 1 going to these pins, and then on the WIZnet chip we want 19, 20 and 21. Oh, and also up here we have Ethernet reset, and we have a couple of chip enables. So we've got IO18, which is chip enable 0, and IO16, which is chip enable 2. And the reason that these are both brought out is that there is an option to choose right over here. You can choose, hang on, why does that say 16? 16 and 18, is that right? Yes, that's right. They're just on different sides. One's on the top, one's on the bottom. So from here there is a jumper which is closed by default. So chip enable 0. Hang on. This could be a problem. Chip enable 0 is selected here. What were we selecting here? Chip select. Oh, I've got chip select is 2 here. I'm sure this isn't going to fix the problem, but let's just do that. Yeah, fail to load overlay. So the so chip enable 0 is the one that is bridged through to Ethernet chip select, and this is the net that goes out to the WIZnet chip. So let's go to the other end of the chain. What sheet is it on? Sheet 2? Yes, Ethernet controller. Alright, so got to get the zoomage happening over here. So here we have 19, 20 and 21, Keepo, Copy and serial clock, same as before, so that matches the other end. And then we've got Ethernet chip select. Now, interestingly, is there any bias resistor on chip select? I have a feeling there isn't, and I don't know if that's a problem or not. I think it probably doesn't need it, but I've never actually noticed that that doesn't have one. So what there would usually be is something like a pull-up resistor on the chip select line, just like another 10K resistor. Oh, and you can see the Ethernet int line there as well. Same thing, so the int line has a pull-up resistor to 3 volts, and then it's asserted by pulling it to ground. Chip select should be the same. But if we're explicitly driving it at the other end, it doesn't matter. But just as a general principle, there should be a pull-up resistor on Ethernet chip select. So if we go back to the other end, we can see that there's nothing. There's and also I'm using the terms chip enable and chip select interchangeably. And here we go. We've got chip enable 0 and oh, someone just messaged me. I'm not sure if... Oh, okay. I've got some DMs to check. I will get back to that in a moment. So, yes. Anyway, what we're doing is taking whichever of the pins is set as the chip enable and taking it through to the chip select pin on the WIZnet chip. But what there really should be is a 10K resistor here on the right hand side of these jumpers. Now, I don't think that the choice of chip enable pin really makes a whole lot of difference there. It doesn't make... yeah, so Austin says, is CS0 SPI dev disable a problem? Yeah, possibly. But this is where I'm still... where were we doing that? Okay, so let's change this. SPI dev, CS1, CS0s, they're all disabled. So it's disabling chip select 0, chip select 1, and chip select 2. I don't know. I don't understand what this is doing. I can take guesses, but I don't know. And guesses are not the same as knowing. So at the moment I am cargo culting this. I am just taking it as face value that this is what is working on Tony's hardware, so that's what I'm going to use. Tony says no, that's to stop the default SPI driver so that the W5500 can take over. Cool, that's useful to know. Right. Yeah. Henrik said... Oh, okay, so Henrik has sent me some stuff in private message. I am just going to have a quick look at that. Failed to apply overlay. Yes. Thanks, Henrik. I'm just going to open that link. I have a feeling this may be one that I came across yesterday when I was looking for this. Failed to apply overlay. Yeah, I'm not sure. I might get back to that. Yep. Cool. So, thank you. Are you using pin 25 for int? I believe so. Alright, catching up on chat. So, Trady said, is there an issue with your WS5500 driver? I don't know. And Aaron asked, are you using pin 25 for int? Alright, yes, that's a good question. So here we've got int pin equals 25. So this is one of those parts of the process where we correlate what is in the code here to what is in the hardware. And Ethernet int 25, yes. So that was a good question, Aaron, and the answer is yes. I am using pin 25 as the Ethernet int. Alright, so yeah, as Tony explained, an overlay is a method used to activate a driver. Dodgy asked, the function of the W5500 chip is, it is an Ethernet transceiver. So the very brief summary of this is that what I'm trying to do is take a Raspberry Pi 02 and add wired Ethernet to it. And yes, I know there is a whole question about why not just use a Pi 3 or whatever. I've talked about that on previous live streams. There are mechanical reasons, and I'm trying to, it's for the form factor basically, so that I can put the Ethernet connector where I want it on the edge of the board and add all the power over Ethernet stuff that I want to add. That really is the reason for doing this. If I could just stick a Raspberry Pi 3 in there, none of this would be a problem. Right. Probe the chip, see if something looks suspicious. Yeah. I don't think we're at that point, Aaron. I think we're still at the point of trying to figure out why it is that the kernel will not load this overlay. Well, yeah, fail to apply overlay and the reason for it. Okay, so one of the interesting questions, this is something that Tony saw yesterday, he noted yesterday, is you see how it's got this 1_ prefix. In fact, if we just do DT overlay list, what have we got now? You can see that this is what happened with the first one, and it was successful. So SPI1 3CS, this has been loaded, and then it has not loaded. So early on, when I did DT overlay list, we had no overlays loaded. So it's now successfully loaded that first thing. So this command worked. But then when we get to this command, it fails. And I think it is something environmental related to this. But I am out of my depth here. I'm not even sure where to start debugging this. And the thing is that when you... Okay, let's bring this back over here. I'm going to bring up another terminal on this same machine. Oops. Because what I want to do is var log syslog. Yep. Alright. So we've got the syslog on the right with my face kind of obscuring it. But watch what happens when I do this command. So this is trying to load this overlay, which in turn should load the driver, and watch the right terminal. Alright, so we get a single entry in it. I'm going to bring this over here so you can see it. Look at this. So kernel error, overlay warning, memory leak will occur if overlay removed, property blah. So let's have a look at that. So what, because I don't know anything about this, I'm just reading this at face value. My interpretation of this is it's saying an overlay is going to be removed, but that might mean that in trying to apply this overlay, it's trying to remove something else. But let's just have a look at, nope, not that. I want that. Can I copy it? Yes. No such file or directory. Okay. I wonder if that's because of the @ symbol in it. SPI, no. No, yep, that must just be like in memory space or something that is not being mapped into the file system. Tony had an interesting suggestion. Try and activate the standard W5500 overlay, reboot, and then type sudo DT overlay W5500. Yes. Okay, so let's DT overlay, let's clear the decks here and see what we're working with. So we've got one overlay loaded. Now if I do sudo DT overlay W5500, will that do anything? Failed to apply overlay. Okay. Is that how I would have applied it? DT overlay SPI1, blah, Mac equals that. Let's just try, I don't know what I'm doing, but let's just try that. Unknown parameter Mac. Okay, so it's not accepting that. Turn it off and back on again. Yes, need to reboot first. Okay. Sudo reboot. I'll get rid of, oh, I'm back in there. Let's just get that terminal out of the way. And watch for the LEDs to start blinking again. Let's go to, let's go set some mood lighting. Make it nice and romantic in here. There we go. So now we have the, yeah, you can, this is just for Quindor. You can see it all running now. So if I go back to here, let's SSH into this sucker, and then I do DT overlay list. I've got nothing, and then sudo, okay, thanks Tony, DT overlay W5500 int equals, int equals 25. So this should load the default driver. I don't know, parameter int. Okay, so it's not liking the interrupt parameter. Let's just see if I can do it with no parameters at all. Don't know if that'll work. Fail to apply. Okay, and it's got a 0 in front of it. So my my interpretation of this is that what it's doing is incrementing an index as it's loading overlays. So it's trying to load the first overlay, which is assigning it index 0. So that's why when it reports it, it's showing that, even though that's not part of the name of the overlay. Okay. Right. So, hey, I got something right. Int pin. Yes, thanks, Austin. You're right. It should be int underscore pin, I think. Fail to apply. That is interesting. All right, so what this is telling me, I think, is the likelihood that there is a problem in the environment, and maybe I have screwed up the environment in some way. Michael says denied. Yeah, demessage. That doesn't show anything, Austin. Like if I do demessage, it only has this. See, this is the thing that was coming up in the syslog earlier. Each time I try to load it, it just says warning, memory leak will occur. Memory leak. So fresh OS install time, Scott. I think you are right. Tony said I was getting this and so went to a new OS. I have a feeling that my next logical step is a clean installation of Raspbian OS, and then but I'm just thinking through the implications of what that means. I can set, with the new Raspbian imaging tool, you can set the Wi-Fi details, I think, because I'm thinking through whether I need to connect a monitor and all of that sort of guff. Can you put the message in the chat? Yes, I can. So this is, hang on, I have to use the menu to copy out of that terminal, unfortunately. All right, that is the memory, that is the error that I'm getting. So Henrik, if you want to play around with it. But yeah, this is really feeling to me like the environment is screwed up in some way. And, oh, thanks DIY, yes, DIY confirmed. I can enable SSH and Wi-Fi in the imager. However, what I don't want to do is lose, all right, let's, this is good. This is something that bites me from time to time as well. I'll be working on something like setting up things within a Raspberry Pi, and I'll be working on scripts and making config changes, and then the only place all of that exists is on the Pi itself. And if it needs to be re-imaged or something, then I don't have a way to reapply those same changes, which is one of the reasons that I try to keep all those notes that I do. I was showing that notes file earlier as I work through the process. But what I need to do now is things like the read button script, the RGB rainbow thing, What else was there? See, there's RPi WS2811X. This is something that I was playing around with to try to get it working. I need to make copies of the stuff that is on here. So let's do that. And then we can rewrite it. And part of the reason for that is it's kind of embarrassing, but I've run out of SD cards. I don't think I actually have another SD card. Or do I? What is on this one? There's a 16 gig SD card here, and I don't have a clue what's on it. I'm not sure if it's a Raspberry Pi image or what it is. I have a feeling it might be. And it may even be the one where I got the MAC address ROM running. So I've just plugged it in and I'll see. Oh, it's called disk image. No. Oh, okay. No, it's a oh, hello world. It is oh, what's in test? Test? No. No, okay. That is one that I can nuke. So that's fine. I'm going to re-image it because but I do still need to copy off I need to copy off these things so that I can apply them on the clean image. Clear, let's say mkdir from test1 cd from, of course there's nothing in there, what am I doing? And this is just to make, was it Scott that I was making mad earlier by using IP addresses? I think it might have been. Read button.py. What else? I've got the GB rainbow. Of course autocomplete doesn't work when you're trying to specify a remote file name. And RPi WS281X. And what else will I copy? I'll copy my W5500 overlay. I don't need to copy because that's what we've already got. Maybe that's all it was. It might have just been those things. And the thing is that read button and all that sort of stuff, that's easy to reproduce. Okay, that'll do. That'll do, donkey. That'll do. So, now what we can do is, where is Raspberry Pi Imager? I'll just leave that one running for now. At least we can go back to it later if we need to. If I do nuke it, oh, there is a new version of Raspberry Pi Imager. If we do end up nuking, sorry, trying to do things while talking, download for macOS. I am downloading the new Raspberry Pi Imager, and then we will make ourselves a nice fresh Raspberry Pi OS. I'd like some Raspberry Pi, as in a real Raspberry Pi. This is not very exciting viewing at the moment. Keys. Yeah, I know, I should have copied an SSH key in there. Alright, here we go. The new version of the Raspberry Pi Imager. Choose OS. Raspberry Pi OS 32-bit. That's the default. I assume that this is the one that everybody else is using. Which one am I looking for? That one, 16 gig mass storage device, and I want to set host name. Yeah, let's do it this way so that I can stop typing. What are we going to call this one? IOTAP1. That'll do. I don't think I've got one of those on my network. Enable SSH. Yeah. Public key authentication. Yeah. Set a username and password. Yeah. I wonder if you can see. If I type, I'm going to set a Let's see. I assume it's not going to show it on screen, but I'm just going to do that. And configure wireless LAN, yes. I want Superhouse, and you do not need to know. Oh, how is that? Oh, show password. I just partially doxed myself, but that's okay. Wireless GB country. If someone wants to come and sit out the front of the lab and steal my internet, that would be entertaining. Hang on, were there any other options below that? Set locale settings. Yeah, stuff it. Let's set that. Play sound when finished, eject. Yeah. Okay. Go. Yes. Password required again. Okay. Writing. Now, this is not necessarily the fastest SD card, which may not be ideal, but right. Can we see the app? Oh, Aaron says Control-Shift-X for advanced menu for Wi-Fi credentials. Oh, okay. Oh, there's a fancy cog icon now. Yeah. Sorry, I'm behind on the chat. Scott says we need to drop ship John a case of SD cards. Yeah. What I need are small SD cards, like 8 gig, maybe 16 gig SD cards. Because they're useful for just little things on Raspberry Pis. And at some point in the past, the local Officeworks was discounting out a whole bunch of SD cards. I think they were 8 gig. It was one of those cases where they were kind of end of life, and they were selling out a bunch of them for like $5 each. So I went and bought a few, but that was a few years ago, and they are now all used up, used for different things, archived in different places. Okay, this time I will mute before I take a swig. Delicious dihydrogen monoxide. Good stuff. 100% proof. Right. Okay, so Tony asked, DIY in the ghetto, he said you had the W5500 working, what overlay did you use? Right. Yeah, so there was a tutorial that DIY in the ghetto followed, and it is where, let's see if I can find it. I probably can't. I'm not sure where. Oh no, I might have put it in my notes. Notes. What am I trying to open? I want to open Finder and Notes. Did I put it in here? Maybe I didn't. Oh yes. No, that's a different one. So there are a few tutorials around on how to use a W5500, which I looked at before I actually did the hardware design on this. And there are, so I don't think this is the same one that DIY was talking about, but this is another one. So this is on Stack Exchange, adding a LAN module to a compute module 3. So this is with a CM3, not with a Raspberry Pi Zero, but there are various things like this. Here we go, did a short test with an RPi Zero, okay, and everything performed as expected. But this would be on SPI 0. So the thing is that the tutorials that I've seen have been using the default W5500 driver on SPI 0. And most of them are basically following the same process. They've got some connections on here. They're telling you to load the 5500 overlay, setting some parameters, and everything should work. But because we're using SPI 1 instead of SPI 0, oh great, verifying. Hopefully this will be faster than writing. the tutorials are useful, but we can't just follow them exactly like a bouncing ball example of do this and then do this and then do this and then it works, because some things aren't quite the same. Enric, thank you for the super chat. Enric said, just buy faster SD card with the €2 I've sent to you. Thank you. DIY in the ghetto said, I don't have the admin rights to post it. Oh, okay, that's I guess that's the link. Tradie Trev said, I found an instructable for the Pi Zero W5500 Ethernet. Yeah, I've seen the basically the same tutorial, or almost the same tutorial, is on Instructables and yeah, it's all over the place. That one that I just showed you. And they all follow those same sorts of steps. Can you post that link, John? Ah, I see. So DIY, hang on, let's see if I can do, no, I can't do that. Where is the list? Oh, participants. DIY. What can I do? No, what I was just trying to do was give DIY, hang on. What is going on? I've just lost the chat. Oh, now it's back again. Oh, Sion, you're here. Cool. Ooh, VNA day for Sion. Nice. What I was just trying to do was add you as a, give you admin privileges so you could post things. But that didn't seem, I couldn't work it out. I'm not clever enough. I'm just a simple guy trying to figure my way through things. So W5500, I'm going to post some links here. W5500, Raspberry Pi, Instructables. Yes, so this one, let me see. I'm going to post some links just in case people find them useful. This is one of the tutorials. This is not on a Pi Zero, this is on a Pi 3, but it's using a module to add a W5500, Raspberry Pi Zero. It's almost finished verifying. Then there is this one. Sion says, sorry, I'm fighting with my VNA again today. No luck or help from Siglent still. And I'm way behind getting things matched and ready for production. Oh, that's frustrating. Sorry to hear that, Sion. What else? What else? Raspberry Pi Zero Ethernet LAN. There's another, yeah. If you search for W5500 Raspberry Pi, there is a lot. There are many different guides and things. Dodgy asked VNA. Yeah, so network analyzer. It's I am not the person to be explaining that. Ah, right. This is done. Continue. So now I can eject. Now I can grab. I'm not the person to be explaining it. That's what I was trying to say. It's used. They're used for doing things like tuning circuits for antennas, like doing antenna impedance matching and all that sort of thing. All right, where are we? Let's get back to here. Pi at Raspberry Pi. What did I call it? IoT AP1. Let's just shut this one down. And has activity stopped? Activity has almost stopped. All right, back to here. So this is where the action is happening. Yeah, there's nothing. All right, let's totally power it down. Pop out the, yeah, the mood lighting doesn't work so well when we don't have those LEDs. So this is the SD card that I just flashed. I'm going to stick that in and power it back on. Oh, what I should have done. Yeah, this is not going to show the RGB LEDs when it finishes booting, because that magic was added on the other SD card, and it was in cetrarc.local, I think, that was happening. Let's try. I assume it's going to come up on the same. I should never assume, on the same IP, because it'll have the same MAC address, so it'll be allocated the same. It's going to have a different key though, so I will probably get rejected. Let's try IoT AP 1.local. Yeah, it could be, if this doesn't come up on Wi-Fi, then I may have to plug a monitor into it and do some messing around. All right, while I'm just leaving that, it's either going to come up with a could not connect or could not resolve any moment now. Could not resolve that IP, of that host name. Oh, it's so bright that I'm having trouble seeing where the screw heads are. I need to remove this from the enclosure in order to plug in HDMI. And, oh, come on, come out of there. So, so Ross said it's a Pi Zero, not a compute module. That's why he's using 32-bit Raspbian. I used 32-bit because that was, oh, hang on. Maybe I don't have to take it out of the enclosure. Yes. Aha, nice. We're in, as they say in all the hacker movies. Okay. Let's just do this as a very first thing. Make sure that we've got everything up to date and a nice, totally clean Raspberry Pi OS installation before doing anything else. Oh, I need a stretch. Need to do something physical. I've been too stationary the last couple of days. I haven't been doing enough exercise. All right, sudo apt dist upgrade. Do it. Do it, do it, do it. The wind outside has got up. It's blowing around like crazy. All right. Now, what's going on in chat? Where is the chat? I've lost the chat window. Oh, there it is. Okay. Yes. Aaron said Pi 02 can run 64-bit, right? I don't know. I assume so. Oh, Aaron said it's essentially the Pi 3B Plus. Yes, as far as I know, that is what it is. So I'm just going to open up the imager again. Imager. I know you can't see this because we've got. Oh, there we go. Yes, so choose OS. What I did was I just went for the first option. I just picked the default. Raspberry Pi OS other. Let's go for that. And then we could pick Raspberry Pi OS 64-bit. It would be interesting to know actually what Tony's using, because ideally I'd want to have the exact same environment. Yeah, Pi 0 only runs 32-bit as far as I know, but the Pi 02 is 64-bit. Yeah, so thanks DIY. Yeah, so at some point it might be worth me re-imaging, starting with a 64-bit OS. But since we got this far, let's just see if it does run. Okay, so Tony says I'm running 32-bit from the very latest OS. Awesome. So what I'm setting up here should end up being, in theory, should be identical to Tony's environment. It's a clean Raspberry Pi OS installation, as you've seen, and I'm updating it to the latest. And then we'll follow the steps from the beginning. All right, so while we're waiting for that to happen, what else is going on in people's lives? What's happening in the world? Oh, Dodgy asked, do both of them have the same pin config, Pi 0 and Pi 02? Oh, interesting. Oh, Tony said, how about I post an SD card? Oh, like actually physically post? That, if I can't get the environment to work, that would actually be a really nice way of validating it. So hold that thought. If you have got an image that is working on your, yeah, as Aaron says, or copy the contents and send it digitally. Yeah, you take a disk image and then post it somewhere and I could grab it. Funny thing is that when you're dealing with lots of data, sometimes it is easier just to stick physical media in the mail. You know, it's that classic story of there's not much that beats the bandwidth of a carload of hard disks for just bulk transfer of data. Ah, DIY. Oh no. Said I found out. Oh no, that's good. I misread it. I thought it was bad. DIY said I found out I don't need spinal surgery yesterday, so that is what's going on with me. Well, that's a relief. Yeah. Cool. That is good news. Oh, RPS said, I sent you an email last week. Please call ASAP. Regards, Richard. Oh, okay. I will check for an email, Richard. I don't remember seeing one. That doesn't mean it's not there. It is quite likely it is there, because I currently, what am I at? I'm somewhere in the region of 50,000 unread emails right now. I think the last time I checked it was around 46,000 unread emails. So it's, yeah. It can be hard to get my attention, unfortunately. I only have a small amount of attention that is very scattered, as you've seen. Ross Flamingo said, Sneakernet, yeah. Tourist said, latest may be good, but when were the docs and tutorials dated from? Hey, Tourist, I don't think I've seen Tourist in the chat before. Welcome, Tourist. There was a major change recently in the Raspbian OS version. Remember having to use the installer legacy version for some project. Yes. That is a good point. I don't think that is the problem with me, because Tony has mocked up this hardware. He doesn't have the exact PCB as me, but he's mocked up the functional components and he has got it running with the latest 32-bit Raspbian OS, which is what I'm installing right now. So hopefully I will end up with the same software environment as Tony has been running. Ah, Cable Tie says, I'm building holiday lights. How do people do level shifting? Simplest way, preferably not with a new PCB, to have an ESP32 driver WS2815 12-volt string. Ah, okay, Cable Tie. Interesting. There's there are two different things here. You're talking about a 12-volt string. My guess is the 12 volts is the supply, that is the supply side to all of the LEDs, but the logic pin is probably going to be 5 volts. So my guess is that what you're talking about is level shifting from 3.3 volts to 5 volts. Okay, there are a couple of ways to do it. I have level shifters. I can give you a level shifter board that'll fix it. But there is a sneaky trick. 5-volt is logic from that string, yes. That's right. So the supply side, like 12 volts or 24 volts or whatever, is to provide the main, like the power to illuminate all the LEDs, but the logic level will run at 5 volts. And the crazy trick, I've actually got slides from this while we're waiting for this update to happen. Dropbox talks, I've got a conference talk from a couple of years ago, and it was for, maybe, was it in the Swag Badge hardware talk? I can't remember. Let's see if there is a schematic in here. No, there's not. No, it wasn't that talk. Was it the year before? No, opening. No, it wasn't that far back. Testing the Swag Badge. No, it wasn't that one. Custom input devices. No. Can't have been that far back. I'm going back through my list of talks, and I can't see. Maybe I don't even have all my talks on this computer. How many do we have here? I've got 104. I've got about 144 talks on this computer, but I might have done more than that. Anyway, level shifting. I am absolutely sure that at some point, open hardware, donkey car. Was it here in the donkey car? Yes, here we go. Here we go. Okay. Time to show you the trick for running 5-volt LED strips off a 3.3 volt logic thingamajigamy. Okay. Oh, look, that thing's finished. All right. So here we have. I will get through this quickly because I want to get back to the W5500 because it's already 11:30. All right. So here we have the classic WS2812s running with 5 volts on the supply side, and they have 5-volt logic on the data in, and then they daisy chain out to data in, and so on and so forth. So we need 5 volts here in order. Normally this is what happens, is you run all the LEDs off 5 volts, and that means that you need at least 3.5 volts for a high signal on the input line. But this is the trick, and so what you can do is prepend your LED string with another LED. So this could be just like a single separate WS2812B, and you power it from 5 volts, but you put a diode in series with the power supply pin. What that does is it drops the power supply to 4.4 volts. So the first LED is running at 4.4 volts instead of 5 volts. That means that you only need 3.08 volts on the data in pin in order for it to see a logic high, and hooray, it works. But what happens is that the output here is high, is 0.7 by VCC, is 3.5 volts, and that one then works as well. So basically all you do is you add one diode so that you're running the first LED in the string off a slightly reduced voltage. It brings the input pin into compliance with its acceptable high and low range, and the output pin here is high enough that the next one in the string is also happy. So let's get back to this now. Where are we? Okay, DT overlay. So we are now in a clean from test one. Okay, let's get back out of that. Resources, SCP minus R. Okay, just to get rid of that OCD, I'm going to. This is my local copy of the thing. There we go. Whew. Sigh of relief. SCP-R, W5500, and I want to put it on pi at iotap1.local, and done. Alright, so now we should have W5500 overlay. And if I go into that, let's do the thing. So what we can do is CP this overlay, or hang on, I need to be watching chat because I don't want to be rushing ahead, screwing this up, and Peter, 33-minute warning, and doing something before I should. So now don't forget your rainbow. Yeah, we'll fix that, but yeah, time is getting short and I do want to get this Ethernet working. Imagine the space was the origin of the error. No. Okay. Okay, to be sure, copy overlay from Discord IoT access point. Yes. All right. To be sure, to be sure. So what Tony is suggesting is that I make sure I'm actually using the latest, the overlay that has been posted. And in Discord there is a topic for the IoT access point project, and I am in there right now. I'm going to download the most recently posted. It was posted on, when was that? The 6th of November. Alright. I am now downloading the latest show in Finder. This should be the same as the one that I have I've just copied over. But Tony is correct that we should be making absolutely sure. In fact, what I'll do is let's see, MD5 sum W5500. What have we got? That and on the local side, clear W5500, and I will copy today. Okay, so this one, I'm just going to copy it in, replace, yoink, and if I do that again, we should see the date of modification has changed. So now we can see that it's newer. MD5 sum. Is that going to work? Okay, that's annoying. Alright, let's just copy it over. SCP W5500 to pi at 1.local, and where was it? Into W5500 overlay. Boink. Alright, it's copied over. And we can see the modification date has changed, so it's definitely the most recent one. Okay, so I won't do that yet. Let's do sudo cp w5500 into boot overlays. Better check that I'm still doing the right thing before I do anything else. I just got a DM from someone. You need a reboot. That's okay. Thanks, Maina. That is because there was a kernel upgrade. So let's just make absolutely sure. Yes. And Austin said the same thing. There was a kernel upgrade. Sudo reboot. Among those packages that I updated when I did the dist upgrade. So while this is rebooting, something I need to ask. Is the audio coming through okay? Because it's looking really hot on the VU meter. And I noticed a couple of live streams ago, my microphone was kind of clipping. It was really loud. Yeah, it is. Okay. Audio excellent for me, says Michael. I've always wanted those. It's fine. Audio is good. Okay, cool. VU meters lie. Yeah, I've dropped it a couple of notches, but it's punching into the red, and particularly when I get animated. Now, what is going on with this? Has it rebooted? Why have I got nothing? I should be getting my terminal back if it's rebooted. Yes, it's a WS2815. Okay. Read the rules, go away to bottom. You have to perform an action to release the goods. Yes. Animate more, says Chip. Animate. What? Why haven't I got my terminal back? This is not a good sign. Not happy, Jan. Let's try. Let's just try SSHing into it from this other terminal. Pi at iotap1.local. It did take a while to come up the first time, so maybe it will take a while this time as well. Turn it off and on again. Yeah, it's a little bit too soon to do the big power cycle. Aha! I have a login. Yes, it was just taking a while, so let's get back out and we will restore our terminals to their original purposes. So that's my local terminal, and one on the left is the target terminal. Alright, so CD into W5500 overlay. I had copied that in, hadn't I? So ls boot overlays. Come on, autocomplete. Why? What? W5500. Yeah, so it is now copied in there. Alright, we're getting closer. We may get to Ethernet, people. That would be so cool. So cat start Ethernet. Let's do all of this in one go. Aha, Richard, thanks for the super chat. Buy some SD cards, add the rest of the Christmas fund. Thank you, that is very generous. Okay, so we've now run most of that startup script. I deliberately didn't just run the script because I wanted to see what happens at this next point. We now have this MAC address set in a variable in the shell, and now I want to do this. And then, moment of truth, this is it. Are we going to get anything? Yes, cable tie, you're right. That Richard is extremely generous. All right, please, please, please work. Oh, no error, no error. If config -a. Oh, that's kind of disappointing. But change CS. Yes, yes, yes. Okay, change CS. CS should be 0. CS should be 0. Failed to apply. I think that's because it was already applied. So perhaps, is there a DT overlay remove? DT overlay, oops, list, DT overlay help. Remove an overlay by, okay. So we should be able to do DT overlay -r. So remove, and it is overlay 1. Oh, of course. Sudo make me a sandwich, and now let's do it with the correct chip select pin, and then do if config -a, and now what's our next step? Okay, what do we do? I'm kind of so brain fried by having got to this point without an error that I'm now lost. So I would want to be doing an if config remove, about to find out, yeah. Sudo. Sudo or sudo. I don't know. Or Sadu. We could come up with our own pronunciation for it. Put the emphasis on the wrong syllable. I've always said it as sudo because what it's standing for is super user do. I think that's the origin of it. But maybe it's not. Sudo. It's do. Scott says it's do. Super user do. Yeah, that's right. Yes, you do. So super user do. Make me a sandwich. Now, could I do is if config. I'm trying to remember. Is there even if up eth0 unknown interface eth0? All right. So where do we go now with configuring this? Peter asked, I missed the bit about $adder on the Mac. Is that hard set before the DT overlay call? It is set in the environment. If I do echo there, it has been set. Yeah. So this is meant to be called from a script that does this series of events, including setting up the value of the MAC address, which then gets passed through when the overlay is loaded. You don't have an ETH0, WLAN 0, or LO. I do have an LO and a WLAN 0. All right, please, someone. Okay, yeah, it should be there now. So it should be there as an unconfigured interface. And interestingly, very interestingly, have a look at this. There is nothing, no activity on the WIZnet chip that we were getting some activity on before. I'll unplug the network cable. So that looks like it is not initializing, or the Ethernet chip is not being initialized, even to the extent that it was before, which is strange. Peter Lawler says demessage, Austin says reboot. Do you have to define ETH0 in your networks config? I don't think so. The networks config will tell it the configuration to apply to the interface, but the interface should be there. Yeah, Richard says when in doubt reboot. Let's try reboot. That is, okay, demessage and then reboot. Ooh, I wonder if that was from the previous attempts when it failed to load. Okay, no Peter, I am not going to hit it with a hammer. Now the thing is that if I does nmcli network manager is not running. Oh, that nope. If up should be right, yeah. So do you need to pull up the reset line on the W5500? Is it a GPIO? Yeah, that's an interesting question, Tony. So the reset line on the W5500 is where are we? Reset, Ethernet reset, there it is. IO17, Ethernet RST, and it is going to a GPIO. Interestingly, I do not recall this pin being declared anywhere in the configuration, so I don't think we're actually using the Ethernet reset. It's just being pulled high. But if that was being pulled low, so this is something I could chuck the multimeter on it and check. If this pin was being pulled low, that would hold the WIZnet chip in reset and it would never initialize. So that is a valid thing to check. Oh, hang on. Once again, I'm doing the stupid thing where I'm looking at the screen and you can't even see it. This is what I was trying to show you. The Ethernet reset going to the WIZnet has a 10K pull-up resistor to 3.3 volts and it's running off IO17. So this is what I was saying is, if IO17 is floating, this will be high and everything will be good. If IO17 is being actively driven low by the Pi, then the Ethernet chip will be held in constant reset. Now, where is the chat, just to see if I'm missing things. Scott said to restart networking. Yes, let's do that. Could be as simple as that. Where's my terminal? My terminal. There we go. Okay. Still no ETH0. And still no activity on that. CS was indeed changed. Yes, we can't see what you're writing. Yes, sorry, DIY. Pull up on the reset line for the WISNet chip. Yeah. Yes, measure the volts and watts. If config -A, lots of suggestions here. Okay, now that it's been brought up, I am really suspicious about that reset line and GPIO 17. So let's see, let's check the voltage on that. Let's go to here and IO17, IO17 ether reset. Where is that pin? Where is it? Let's do a show on that net. There it is. So it is this pin right here in the top left of the chip. Now, where can I find a convenient ground point? Oh, there are many ground points. Alright, so I want to see if this point right here is being actively driven by the Raspberry Pi. So I'm just going to turn off the mood lighting. We'll go back to harsh clinical lighting and see what voltage we have on there. Where's the ground? Where's the ground? It's oh, there's a ground up there. Okay, that should be a ground, I think. Oh, you can't see what I'm doing, of course. So that should be a ground, and that point there is the end of the pull-up resistor. It is on 0 volts. That is interesting. So the Raspberry Pi is asserting that pin, which is holding the okay, I'm going to fix that. I'm going to fix that the nasty way. Now, am I going to do surgery on this patient while it's live? I think I am. I'm going to buzz that track and this is going to be a nasty thing. Nasty thing. Don't do this at home, kids. It's a bad idea. In a moment I'm going to get the microscope up. Where are we? Microscope. There. All right. And I've got to get it in the right place and get some focus happening. So there. Focus. There we go. So this point. Where's a poker? I need something to point with. Get back there. Where is it? Where is it? There. Okay, so this is the WISNet chip. This track right here, and this is live right now. This Raspberry Pi is still running. That pin is the reset pin for the WISNet chip, and that is the 10K pull-up resistor. That via goes through to GPIO 0 whatever up on the Pi. So what I want to do is isolate it from GPIO. I want to keep that pull-up. So where does that pin come out? It'll really suck if it's on the other side of the PCB, because then it's not a simple matter of buzzing it. No, I'm going to have to take the PCB out of the yes. If you want to set pin to output and set to high in terminal, do this. Raspberry GPIO set X op, Raspberry GPIO set X DH. Yeah. Let's zoom out. Drill small hole on the via, Mad Techie says. Hang on. I'm going to see how practical it is to extract. The thing is, I'm going to have to shut it down because the power. Yeah. I would have to shut it down just to get it out of the case to get to the other side of the track. So let's go for a different plan. Let's go for setting that GPIO here. Let's go for setting that GPIO instead, as was suggested. So I did want to cut that track live. That would have been funny. But, okay, so the reason I can't actually do it is I need to take the PCB out of the enclosure. To take the PCB out of the enclosure, I have to unplug the power cable, which would mean shutting it down and then starting it back up again. So let's just go for the simple way to do this. DIY says just short it all. Okay, so Aaron is saying X being the pin number. Yep, okay. Let's do Aaron's suggestion, which is, helps if I can spell, Raspberry GPIO set, was it 17? I can't remember. Let's have a look. Pin, yeah, IO 17. So set 17, and we want to set it to, where are we? I'm losing it in the chat. Op DH. What are op and DH? Oh, op for output. Output, or what is DH? Set D high. Okay, op output. Okay, so if I do this, that'll set it to an output. And then if I set 17 to DH, that sets it high, is my guess. Yes, okay. So, interestingly, I'm curious to see if this actually worked. That would be quite cool if it did. Let's get some voltage metering on here. So, ground is there. Ugh. Yeah, I know. It doesn't really matter which multimeter probe I use, but I just want to see a positive number. I am not seeing... Oh yes, now I'm seeing 3.3 volts. And look, we've got LEDs. I think we might be getting there, folks. This is really cool. Thanks for everybody's help on this. This is awesome. Let's just do... let's do that again, and then... Nope, still no ETH0. So, what else shall we try? Reboot. Yes, if we do a reboot, that is going to undo setting that that I/O pin. Demessage, dang it. All it ever does is say this, Peter. It doesn't give us anything useful. Does chip enable need high or low? I believe it needs... that's a good point. It probably needs low. Let's see. 17. Oh, it's a reset pin. So, oh yeah, and chip enable... Yeah, okay. But chip enable is being configured, is being handled by the driver. So that shouldn't be a problem. What have we got? So we've got chip enable 0. So IO18 is the one that's selected. And in... Let's get rid of all of this rubbish. Let's go back to where that command was called. There. Chip select 0 is what is set here. Int pin 25. Mac blah. Alright. Int pin 25. Int 25, yeah. And we've got chip select 0. So hopefully we're getting close. Right. Oh, Mad Techie says, try reloading the overlay now. Maybe it was in reset at the time. Yeah. And Dodgy said, is there some way you can make that pin set permanent so you don't forget it and reboot? 4 minutes until lunchtime. No. Oh, I really wanted to get to this point. I think there's a network device definition file that needs to be created. No Ethernet equals no lunch. We're all going to be very hungry, Aaron. Now, if I just do this again, it's going to error because it's already listed DT. But you're right. Let's undo it. So DT overlay minus R1. So we'll remove. Oh, of course. I always forget the sudo. So now we've removed it. Now we can apply it again. And look at that! Look at that! Wow! Okay, Dodgy. Ken has lunch. Oh, that's amazing. Now the thing is that after rebooting, this is probably not going to work. And so, yeah, winner, winner, chicken dinner. Because, yeah, so this is one of those things where, having gone through these steps, I'm just going to sort of pause and reflect on this for a second, because there are lessons here as well. This is an area, this is like this part of a project is where I can really trip myself up, because what happens is we've just gone through a bunch of things and we've changed a number of things. We don't actually know which of those things made this work. Was it setting the like GPIO 17 high? Is that what did it? I don't know. Maybe that was irrelevant. Maybe it was the thing. Maybe it was something else. So now what often happens is I will do something like reboot or go back to a starting point and then not be able to get back to the point that I was just at, because it was some combination of things I did. So yeah, that made it work. But while this is yes, so anyway, yes, I just saw a thing chat, you know, I go past in the chat saying we need a shell script to set it. Yeah, Aaron said we need the .sh script to set the GPIO high. Yes, okay, so what we need is how is Vim not installed by default? That is just, that's rude. So rude. Okay, yeah, there are a couple of other things that I need to put back in place, like the RGB LEDs on startup. So yeah, and in doing that I need to go through the notes and make sure that what the notes reflect is the actual sequence of things that were done to make this work, to make it reproducible. Because if it's not reproducible, then, you know, it's not really solved. Scott says, need to learn vanilla VI. No. Yeah, VI was probably already there. Thanks, Mike. It probably was. But here we are now. Vim start Ethernet. Where, so what I want to do is in here, where was that command? Pin mode, blah. Digital right, delay, digital right. Austin is, oh, okay. So what Austin is putting in there is the commands to do this, I think on ESP32. Where? I can't remember what was in history. Where was the? Let's see. Control R, DH, and OH. I think were the two things, weren't they? So what we want is start Ethernet. We want that and that. So that should do it, I believe. Let's add a note in here. 17 high to enable the WISNet chip. And is there anything else we want to do? Do we want to change? So we've got chip select. Oh yes, I think I need to change CS2 to CS0. Is there anything else we need? I don't think so. So let's set XDH. Hang on, let me just check that. Raspberry GPIO set 17 OH for out. No, it wasn't OH. OP. It was OP, yes. For output, because OH does not sound for output. OP. And I guess D is for drive. That'll be drive high, or my guess is DL for drive low. Yep. OH equals O heck. Yep. OP and DH. Yeah. So let us let's do this. Live dangerously. We will let it. Oh, digital high. Okay. Thanks DIY. Not drive. It was digital. Oh, that time it went down more quickly. And let's just SSA. Is it gonna? Let's just leave it here, and hopefully it'll connect eventually once it comes back up. Drive is correct. Yeah. Scott says panic. Yeah. Right. Yeah, so all of this, uptime, let's just, it won't have the interface, but if we now go into here and I do start Ethernet, chmod plus X, start Ethernet, let's see what happens. And do we get an error? And, oh, yes, we have an Ethernet interface. But bash history for the win, yes. Peter says, what's for lunch today? I don't know what is for lunch. I hadn't thought that far ahead. I have some sausage rolls in the freezer here at the lab, so maybe that is the thing. Yeah, Michael says that feels like lunch. Yes. All right, so I think that I'm going to go one step further. Yeah, add that to the startup. Yes, that's Trev. That's what I was just about to say. I'm going to go one step further, and I'm going to add that to rc.local for now. That's the like the simplest way to do this. W5500 overlay. That's not necessarily a great location for it, but let's just and start Ethernet, vim, etc. rc.local. Am I going to have to sudo this? I bet I am, aren't I? So let's just do it. All right, let's do home pi w5500 overlay start ethernet.sh. Boom. Let's do that, and let's just reboot. Oh no, I won't reboot. What I'm going to do first is I'm going to try to get the RGB LED stuff working. So back here, This is on the local copy from test 1. Let's see what's in from test 1. Oh, let's just copy the whole thing. scp-r from test 1, and I'll copy it to pi at tap1.local, and that should give us the RGB LED stuff. So from test 1, let's move RGB rainbow back out to there, and I don't know if this is actually going to work. What is, well, I don't even know what's in this. Cat RGB rainbow. Oh, I've got to get out of the directory first, don't I? Cat RGB rainbow. Oh, that's the compiled thing. Okay, yeah, that was the example. So RGB rainbow, I'm going to switch to overhead camera, and let's just see if this works. Nope, permission denied. And yes, now it works. I just sudoed it. Now we have pretty blinking LEDs. Let's go back to mood lighting, since we're about to have a romantic lunch. So kill that, back to here, and what else do we want to do? Okay, so let's go sudo vim, so it was RGB rainbow. Let's do it. Oh, we'll do it after starting Ethernet. We'll do home pi RGB rainbow like that, and so yeah, okay, so let's just look at where we're at. We currently have the interface up. Oh, look, it's even got itself an IP address. Then we want to, and we have the LEDs running, as we can see by looking at, no, they're not running because I killed the thing. All right, what I'm going to do now is just reboot. Okay, I'm going to hit reboot, but first, let's watch it. All right, it is now rebooting. So, if all our dreams come true, what will happen now is in a moment we will get those RGB LEDs doing the rainbow flicker, which means that it'll have finished booting, and then when we log in we should have Ethernet up and running as well. So I'm just bringing up my terminal to try to log back in. So yep, there we go, we have the flickering LEDs. So that part worked, and now back on the terminal I'm logged in, and let's see if config, we have Ethernet, we even have an IP address on the Ethernet. That is so cool. Now just to validate that, I've gone back to my other terminal, so this is my terminal on my local computer, and I am going to make certain people very angry by SSHing to an IP address, because I'm specifically going to SSH to the Ethernet interface, which was 244. Yes, it was 244. So I'm specifically coming in on the Ethernet interface, and I'm in. So I now have a connection, 2 connections to the computer, one over Ethernet, one over Wi-Fi. Ah, we're full of wind today. Yeah. Yes. Oh, DIY says, I'd love to get a copy of that image. Might save me a lot of headaches. Yeah. So all of this is going to be public. The sharing the raw image may not be the best way to do it. I'm not against that. I don't mind putting the image up somewhere, so that you can just DD it or use an imager or whatever and copy it onto an SD card and then run it directly. But I'm also going, now that we've got to this point and figured out those and got past those problems, it's not that hard to set up. So as long as you have the overlay and everything is in the right place, you run the right commands, it should work. So I'm going to stick all of that in the notes. Yeah, the config files and where to find them. Yeah. Right. feel like I need to pause for a breather now. Aaron says, ship it. Peter says, Ken has sausage roll time. Yeah. Trady says, can we iPerf 3 the device? I guess would be the next step to see how fast she is, but it's lunch. Yeah, doing some throughput testing on the interface is definitely in the cards. But what is the time? It's now 10 past 12. Henrik says it's 3 a.m. here, so night time. Yeah. Thanks for coming along, Henrik. I'm going to go too. I've got to pause for breath. Okay. This is going to feel like an Oscars award acceptance speech or something. I have so many people to thank. But no, seriously, I do have so many people to thank. So Tony put a lot of work into figuring out all of this overlay stuff. And there are other people that have sent me links to tutorials and odds and ends. And Aaron, I think it was, had the suggestion about driving the I/O pin, and other people have checked different things. So yeah, this is one of those things where if I was trying to figure this out myself, there would have been a whole lot more Googling, trying to find things that weren't in my head. But luckily, with enough eyeballs, all bugs are shallow. So we got it working together. Aaron says CM4 in V2 is my preference. Yeah, that's probably where this would be likely to go. If I end up really developing this project further, I think using a compute module would be better. But I was trying to go in small increments, and testing it with a Raspberry Pi Zero was easier. And I think I couldn't buy CM4s at the time. Yeah. Yes, DIY says it's a big group effort, and Tony, you are awesome. Yes. Mad Techie says, pat on the back and elephant stamps for everyone. Cool. Well, okay, there is one very important thing to do before I sign off here, which is I'm just on my on my machine here. I'm going to bring up a different view in a second. Here it is. This is the notes W5500, and we say okay. Thanks to Tony and a cast of thousands. All right. Button input. Okay, those other things. Yes. Okay. So I still need to fix the PoE. I might just hack around on that in my own time, not in the live stream. Swap those pins around. I will change the resistor on this, and these other things are not actually essential. We're at the point now where we can make ourselves a Wi-Fi access point by adding in the stuff that I had running on the Pi 3. So on my previous prototype, just running on a Pi 3B+, I had the access point system running with personal pre-shared keys by using the MAC address filters to apply different pass pre-shared keys for each client. I need to apply that. So I think that next live stream we should have a working access point, and that'll be a big moment. That'll be a relief. Okay, I am going to go, and thank you to everyone. Thanks for coming along. This has been a productive live stream. The last 2 live streams have been productive. Now that we've been getting onto this project and working through things and solving problems, it's all working out. Very cool. So I hope you all have a fantastic week, and that you go and make something awesome. Okay, see ya.